Hello, this is our final project for Systems 335. My name is Zaara Fuad.
This is Rula Nassrat.
And this is Natalie Nolan. The problem that we found throughout this study is that 911 responses require immediate resource arrival to save lives. We didn't want to build a model. We wanted to see if the protocols used by real departments are sustainable given the massive data trends we're seeing today. Some constraints we found when analyzing this problem are that unlimited resources are fiscally impossible and that excess capacity is expensive. We wanted to optimize these situations by noticing that current allocation methodology may be inefficient.
To simulate this, we used a discrete event simulation model using any logic. So as you can see, we had created resource pools in the top left corner. We had gotten data from Fairfax County Rescue Department to see the resources that they would normally send for structure fires, for vehicle fires, and forest fires. So these resources are there, and using the research that we had found, we had gotten base numbers for the data, which we had placed into those resource pools. In our source block, we had put in the distributions that we had found from call logs from Montgomery County, as well as the delay blocks also had different distributions showing the amount of time that these resources would be gone for. And then in the bottom section, we have data charts showing the utilization of the different resources as well as different queuing times for the different types of fires. Here is our simulation running. This is using the base numbers. In our model, we eventually increased the number of resources by 25%, then to 50%, and then doubled it. But this is how the base is working. And as you can see, the utilization of these resources is very high, and all of them eventually reach the red zone.
The significance of this model is that it is meant to be seen if the protocols used by departments are sustainable given the current trends that we found through research. It also creates a digital twin that allows the testing of different resource allocations without damage of life or property. This way, the simulation can see if changing the amount of resources will actually affect the results. It can also help us visualize what-if scenarios that aren't feasibly possible to do in real life. This simulation also revealed the non-linear aspect of the system, as 25% increase of resources does not equal 25% increase of effectiveness.
Moving on to our recommended course of action, through our iterations, we noticed that to actually see a significant change in resource utilization, you would need at least a 2 times increase in the resources that counties currently have. Another thing that we were looking into is that Fairfax County Fire and Rescue Department is working or is utilizing a UAV resource system right now for fire incident investigations. And if this was utilized in a way that assesses fires and figures out how many resources they need before they're actually deployed, it could reduce the fire department's response times and allocate these resources more efficiently. Our next step would be incorporating this into our simulation to prove that it would fix the utilization times. Here are lessons learned. For future improvement, we would enhance the model accuracy by simulating different fire severities to better reflect how resource allocation scales with incident size. This is because not all structural fires would require a lot of resources as the protocol currently states. Some of our project challenges were that data acquisition was an obstacle. It required extensive research before we found a breakthrough by contacting the Fairfax County Fire Department. Our key lessons are that early engagement with stakeholders through interviews is essential because we can get accurate data and save time by modeling our complex systems.